Jai Hind to all of you. Today I am going to record a special lecture on addressing modes of 8085. Also we will cover in this lecture various data transfer schemes supported by Microprocessor 8085. This topic is covered under the syllabus Microprocessor with subject code KCS 403. So, moving towards addressing modes. What are addressing modes? The way in which a microprocessor access data from memory are called as addressing modes. Before that, we must know that an instruction consists of opcode plus operand. Opcode defines the operation to be performed by microprocessor, whereas operand defines the data on which microprocessor perform the specified operation. So, the way a microprocessor access data will define various addressing modes of a microprocessor, or we can also say that the type of fetching the operand from in an instruction from memory or IO defines the addressing mode. In an instruction, as I have already told, that an instruction consists of opcode and operand. Opcode defines the operation to be performed by microprocessor, whereas operand defines the type of the data on which specified operation will be performed. For example, if we will write an instruction move A, B, then move is the opcode, that is move is the type of operation which needs to be performed, and A and B are the operands on which this operation will be performed. So, in this instruction, the 8-bit data from B register is copied to A register. So, here the operands are registers A and B, and the type of operation is copy operation, that is move operation. We will take one another example, that is add AB. Here add is the opcode which specifies the type of operation, that is addition, and B and accumulator are the operands. In any instruction of 8085, if we talk about arithmetic or logical work, one of the operand is always from accumulator. So, if we specify another or next operand, so this instruction basically add the content of accumulator plus B register and save the result to accumulator. So, in these two operations or in these two instructions, we have seen that the data is given in registers. Similarly, data can be specified anywhere like in memory, and we can call the data in different ways. So, these different ways are nothing but called as addressing modes. So, if we talk about 8085, there are basically 5 types of addressing modes, or there are 5 different ways in which we can gather or collect data to microprocessor from memory. First one is immediate addressing mode. In immediate addressing mode, the 8-bit or 16-bit data is directly specified in the instruction. We don't need to call anywhere, or we don't need to specify any address. The data is given directly in the instruction. If the instruction consists of 8-bit data, then it is of 2 byte. 1 byte is for opcode and another is for 8-bit data. So, the size of immediate mode instruction can be 2 byte if it consists of 8-bit data, and if this instruction consists of 16-bit data or address, then it is of 3 byte. So, an immediate mode addressing mode instruction can be of 2 byte or 3 byte depending on the size of data specified in the instruction. If the size of data specified in the instruction is 8-bit, then the instruction is of 2 byte, and if the size of data specified is 16 bit, then the size of instruction will be 3 byte. So, we have already seen the two examples in MVI A32, 32 bit 8 bit data, that is 32 is directly copied to accumulator, whereas in 16 second instruction, that is LXI H 2000, H means HL pair and 2000 data is copied to HL pair. There are some other instructions also of MVA immediate mode. We will study those instructions later. Next is register addressing mode. Previously, the move instruction and add B instruction what we have studied in previous slide are the examples of register mode. If the operands are specified in a register or inside the register only, then that is a register mode instruction. And register mode instruction is always of 1 byte, because size of a instruction will only change if microprocessor has to go out, that is either data or address is specified in the instruction. If the operation or only the registers are specified, that is microprocessor has to work inside only, then the size of instruction will always be 1 byte. So, in case of move AB, this instruction just copies the data from B register to A register, and A and B both are inside the microprocessor, the size will be 1 byte. Similarly, in add B, this microprocessor add the content of register A with B and store the result in accumulator, and this is also an inside instruction of microprocessor. Microprocessor need not to take any data or address from outside, so it is also of 1 byte. There are multiple instructions in register mode like INRA. This instruction simply increment the content of accumulator by 1. So, any register mode instruction will be of 1 byte only. Now, we will talk about direct addressing mode. If the address of operand is directly specified in the instruction, it is of direct addressing mode. We have already seen a memory in 8085. It consists of 16-bit address bus, that is the address of memory moves from 0000 to FFFF, that is any address of memory in 8085 is of 16-bit or 4-bit hexadecimal. So, if we have to specify address directly, then 16-bit is required to specify the address, and hence direct addressing mode instruction will always be of 3 byte, because in addition to opcode, that is 1 byte of opcode, 2 bytes are required to provide memory address directly. For example, LDA 2000. So, here 2000 is the memory address. This instruction, for example, if 2000 is this address and at this location there is 32. So, this instruction copies the content of given address to accumulator, that is accumulator 32 is copied to accumulator. Similarly, there are other instructions like STA 2000. This instruction copies the content of accumulator to given address, that is 2000, just opposite. So, any instruction where memory address is directly provided in the instruction, that is called as direct addressing mode. If we talk about memory, address bus is of 16-bit, memory address is of 16-bit, so size will be of 3 byte. So, if the instruction is accessing data from memory in direct addressing mode, size will always be 3 byte. But if this instruction accesses data from IO, in 8085 there are 2 to the power 8 IOs, that is IO address ranges from 00 to FF. So, if it is an IO instruction and the address is provided in the instruction, then the size of instruction will always be 2 byte, one for opcode and 1 byte for address. For example, in 35, in this 35 is the memory address. At this address, the value, say it is 40. So this instruction copies the content of address 35 to accumulator, that is accumulator will consist of 40. So I hope this type of instruction and its size is already clear to all of you. That is, in direct addressing mode, memory address of operand is specified in the instruction. Normally all the instructions are accessed from memory and memory address is of 16 bit. So in direct addressing mode, if we access the memory, size of instruction will always be 3 byte. Specifically only two instructions are used for IO port, that is in and out. In these two instructions, address is of 8 bit because IO port address is of 8 bit only. So only 1 byte is required for address and 1 for opcode. So in and out instructions are of 2 byte only. We consider an example, that is in 35. So 35 is the address of IO port. From this address, the data has to be copied to accumulator. Similarly, if it is out 35, then the value of accumulator is copied to the memory location, IO location 35. So I hope direct addressing mode is quite clear. Now next is indirect addressing mode. As we have already known that in direct addressing mode, we have specified address directly in the instruction. From the name, that is indirect, the address is not directly provided in the instruction, but the address is given in one register pair, and in instruction that register pair is given. For example, we can say that we are considering HL register pair and here 2000 is given. So this 2000 is the memory address and we have to go to the memory with address 2000 and use this data and will perform certain operation. For example, if the instruction is LDAX register pair, that is B, for example B, then this instruction basically copies the content of memory address which is specified in BC register pair to accumulator. Let the content of BC register pair is 2030. Then 2030 is not the data, it is actually the memory address. So it goes to that particular location, copies the content of this location, say it is 45, then copies it to accumulator. So once LDX is run, accumulator will consist of 45. So in register indirect mode, data address is given in a register pair and that register pair is specified in the instruction, that is memory location is not directly specified but indirectly specified using a register pair. For example, if we talk about LDAXB, it copies the content of memory address specified in BC register pair to accumulator. There is another method to specify register pair, that is M. M always points to HL pair. HL pair will work as a memory pointer which is specified as M. So if we use this HL pair 2000 and we write move A comma M, then ARM point to HL pair. HL pair consists of 2000, so it moves to 2000 memory address, take this data and copies to accumulator. So accumulator will consist of 40. Also, to point out HL or to copy the value content to HL pair, we write LXI H9570. So this instruction will load immediately 9570 to HL and this HL will work as memory pointer, that is memory location 9570 will be selected. So these all are the instructions of indirect addressing mode. In indirect addressing mode, again I am telling that the memory location is not directly specified in the instruction. Rather, the memory location is specified in a register pair, and this register pair is specified in the instruction. So it is called as indirect addressing mode. And in indirect addressing mode, as only registers are specified in the instruction, so the size of instruction will always be 1 byte. Last is the implied or implicit addressing mode. So I can say that if there is no operand specified in the instruction explicitly, only opcode is there and it will specify what work needs to be done and on which operand, then it is called as implied mode. So no data is directly provided in the instruction, whereas the data is hidden in the opcode only. For example, if we write CMA, that is only opcode, it specifies complement accumulator. So the data that is accumulator is hidden in the opcode only. So the operand is hidden in opcode only, and there is no need to explicitly provide the opcode separately. Or we can write another instruction, that is RLC or RRC. Rotate accumulator left and rotate accumulator right. So the data is given in accumulator only. So again data is specified hidden in opcode only. There are some other instructions like halt, no operation, and so on. So any instruction in which only opcode is specified, no separate data is specified, it comes in implied or implicit addressing mode. So I can say that there are 5 types of instructions, and also the size of instruction, since no data is provided, is of 1 byte only. So I can say that there are total 5 types of addressing modes: register, direct, indirect, immediate, and implied. Talking about the size, if we talk about immediate mode, in immediate mode data is directly specified in the instruction. If the data is 8 bit, this instruction is of 2 byte. If data is of 16 bit, instruction will be of 3 byte. Remember it. Second is register mode. In here the data is specified in registers only. Since registers are within microprocessor, so size will always be of 1 byte. Third is direct. In this instruction, the memory address or IO address is directly specified in the instruction. If we are talking about memory, address is of 3 bytes, so instruction 2 bytes, so instruction will be of 3 byte. And if we are talking about IO, the address is of 1 byte, so the overall instruction will be of 2 byte. Next is indirect addressing mode. In case of indirect addressing mode, since only the register pair is specified in the instruction, so size will always be 1 byte. And also fifth, that is implied addressing mode, since only opcode is specified, no data or address is specified, so size will always be 1 byte. So I hope I made clear all the things. I will take one example also to specify the difference, like MVI A, 32, LDA 5000, move A, B, STAX B, and halt. So from here I can say that the first one is immediate addressing mode, because data is directly provided in the instruction and size is of 2 byte only. Second is of direct addressing mode because the address 5000 is directly specified in the instruction and the size is 3 byte. Third is register addressing mode because only registers are specified in the instruction and it copies the content of B register to accumulator. So, size will be of 1 byte. Fourth is indirect addressing mode instruction where the address is specified in BC register pair and in this instruction the content of accumulator is copied to that address. So, size will be of 1 byte only. And last, that is implied or implicit addressing mode where no operand is specified, the size will be 1 byte. So, I hope addressing modes are quite clear to all of you. It is a very important topic. Now, we will move to another topic, that is data transfer schemes. 8085 supports various data transfer schemes and normally 8085 transfer data in parallel mode, that is complete 8-bit data is transferred in a single machine cycle, whereas with respect to different programmings, interrupt and DMA, the data transfer changes. So, there are a wide variety of IO devices connected to 8085 and each device or each mode has different type of data transfer scheme. So, if we talk about data transfer scheme, the data transfer scheme is broadly classified into two types, that is parallel data transfer and serial data transfer. Normally, microprocessor transfers data parallelly either in programming or interrupt or DMA. If requested only, that is for longer distance transmission, microprocessor transfer data serially through D7, that is MSB only. So, in case of serial data transmission, only MSB of data bus will be active and all other bits will remain don't care. So, through MSB only the data will be serially input or serially output to or from microprocessor. Now, if we talk about parallel data transfer schemes, in parallel data transfer schemes there are three types of schemes, that is programmed IO, interrupt IO and DMA. During programming, the data transfer is called as programmed IO data transfer. It can be synchronous or asynchronous. If the microprocessor and peripheral are of same speed, then it is synchronous data transmission. Else, normally microprocessor is faster as compared to peripheral, so it will be asynchronous data transfer. In case of interrupt, when microprocessor executes some kind of interrupt, there can be single interrupt line or multiple interrupt line. The data transfer during interrupt is called an interrupt driven data transfer. And when the memory has to transfer a bulk of data to IOs, then it uses DMA, that is direct memory access. We will consider all these topics one by one. So, I have already told you that normally 8085 transfer data in parallel mode, that is 8-bit data is transferred at a time. Whereas, in a lot of situation where data has to be transferred to long distance, it requires single line to transfer data, that is serial data transmission. For this, parallel to serial or serial to parallel conversion will be required. Now, we will consider the data transfer through program, that is programmed IO data transfer. As I have told you that if the microprocessor and peripherals are at same speed, then it is called as synchronous data transmission. So, once the microprocessor request, as the peripheral is of same speed, so the data will be available and it execute the instruction. Whereas, in case of asynchronous data transmission, there is a speed mismatch between microprocessor and IO device. Normally, IOs are slower as compared to microprocessor. So, microprocessor will wait unless the data is ready on data bus, that is called as handshaking mode. Once the ready signal will be 1, then only data transfer occurs. So, Once the microprocessor request for data, IO device will start to read the data. Once the acknowledgement is given, once the data is ready, an acknowledgement signal is given to microprocessor. Microprocessor sends out ready signal and then only data transfer occurs. So, the microprocessor send ready signal to IO device. Once it is ready, unless the data is not available on data bus, microprocessor checks for ready. Once the ready signal is 1, then it acknowledges that the data is ready on data bus and it executes the instruction. So, this is called as handshaking mode. Advantage is that the overall operation speed is higher, whereas it keeps on checking and hence just waiting and checking, which reduces the overall efficiency of CPU. Now we can talk about interrupt data transfer. In case of interrupts, interrupts are basically higher priority request from IO device to microprocessor. So, once the data transfer between IO and microprocessor during interrupt is called as interrupt driven IO data transfer. Once an IO device send interrupt request, microprocessor complete current execution, save the data onto stack memory and release interrupt acknowledgement, and then only the data bus is shared between IO and microprocessor and data transfer executes. So, once the microprocessor send ready signal to IO device, it fetch and execute next instruction and check whether the interrupt signal is low or high. If the interrupt is low, then it keeps on doing fetch and executing the next instruction. Else, if the interrupt is high, it save the status of PC to stack and execute interrupt service sequence. Once the interrupt service sequence is completed, it again push back the status of processor from stack, execute normal operation. In case of single interrupt system, once the IO device interrupt, microprocessor just run the instruction and then go for normal execution. To solve this problem of single interrupt, we have 3 techniques, that is polling routine, daisy chain and multiple interrupt system. In case of polling routine, microprocessor serially checks all the ports one by one and run if the interrupt is available on a particular port and then move on. So, these are various interrupt schemes. Now, we talk about data transfer schemes during DMA. What is DMA? DMA is basically direct memory access. In case of DMA, bulk data transfer executes between memory and IO and the microprocessor will be bypassed. So, we will take an example. Consider various IOs and memory are connected, IO1, IO2, memory. Once a device, IO device has to transfer bulk data to memory or vice versa, it requests the microprocessor through hold signal. Once microprocessor receives hold signal from IO device, it completes current execution, saves the status and release itself or tri-state itself from system buses, that is remain in hold state, and releases the acknowledgement to IO device. Once this acknowledgement is released and the microprocessor removes itself from buses, we can see that there is a direct connectivity between memory and IO, and the bulk data transfer will be executed. Once this will be done, hold signal will become 0 and the microprocessor will again be connected to system buses. So, this is all about data transfer schemes. So, in this lecture we have discussed various addressing modes of 8085. 8085 consists of 5 addressing modes. We have studied various addressing modes in detail with example of each, and then we have discussed various data transfer schemes occurred and held in 85 microprocessor. We can say that the overall data transfer scheme is divided into two terms, that is serial and parallel. Normally 8085 execute data transfer in parallel mode. Only if requested, then it goes for serial data transmission and it will transfer the data serially through D7 pin. During parallel data transfer, it is of two types. During programming, it is programmed IO data transfer, which is of two types, that is synchronous and asynchronous. During instruction execution, during programming, the data transfer between microprocessor and IO is called as programmed IO data transfer. If the microprocessor and IO are of same speed, it is synchronous, else asynchronous data transfer. During interrupt, it is interrupt driven data transfer, and it is of two types, polling routine, broadly of two types, and INTR or ISR. And third is DMA, that is when microprocessor, when IO device requires a bulk data transfer between IO and memory, then the microprocessor will be in tri-state, that is the will disconnect itself from buses and bulk data transfer will be executed between memory and IO. So, thank you all. We will continue with the next topic in next lecture. Thank you.